Elon Musk just dropped 3 bombs that sound impossible. Tesla is now delivering $7,999 tiny houses in California, fully installed in under 2 hours. A $6,789 flying car, tested in Texas with 155 miles per hour top speed. And Optimus robots that Musk claims will hit 1 million units per year by 2027. The first houses are already unfolding from semi-trucks. Optimus Gen 3 launches Q1 2026 with 1,500 programmed tasks. Flying car pre-orders open by year-end. But here's the real question. Can Tesla actually mass-produce all 3? Or is this engineering ambition about to hit a wall? Because the price tags seem too good to be true, the timelines feel rushed, and the technology, it's either humanity's next leap forward or the most overpromised product launch in history. So what's actually happening behind the hype? Let's cut through the noise and look at what's actually happening right now, because the first of these 3 products isn't coming soon. It's already here. Tesla's $7,999 tiny house is being delivered to real customers in California as we speak. Semi-trucks are pulling up to sites, unfolding compact modules, and within 2 hours, people are walking into fully functional homes. This isn't a promise. It's happening. They're building these at the Nevada Gigafactory using the same robotic systems that build their cars. What you actually get for $7,999 is more substantial than the price suggests. We're talking about 280 square feet organized into 4 spaces. A living room that doubles as a bedroom with a convertible sofa bed, a kitchen with induction cooktop and full appliances, a bathroom with rain shower and proper storage. The construction uses steel frames and concrete panels pressed together with 260,000 pounds of force. The walls are fire-resistant, waterproof, and rated to last 18 years. The ceiling height sits at 9.2 feet, which feels more spacious than many traditional apartments. Here's what makes this different from every other tiny house company. Tesla handles everything: manufacturing, delivery, installation, and they're offering free land for the first 2 years in designated zones. The real disruption isn't the house itself. It's eliminating the costs that usually dwarf the actual construction. Traditional housing buries you in land acquisition, permits, construction labor, and fees that often exceed the home's value. Tesla treats houses like cars. Build them in factories, ship them complete, install them fast. Is 280 square feet enough? For a young couple or single person, absolutely. For a family, you'll need additional modules that connect horizontally or stack vertically. The real limitation isn't size, it's durability in extreme weather. Tesla admits these won't withstand major hurricanes or earthquakes like traditional construction. They're optimized for affordability, not disaster zone resilience. The bigger question is whether Tesla can manufacture millions of these units. Because if they scale production the way they did with electric vehicles, they're rewriting the entire affordability equation for home ownership. And that connects directly to the second product, which started as an industry joke and has become something far more serious. When Elon Musk announced a humanoid robot in 2021, the first prototype was literally someone in a costume dancing on stage. The internet laughed. But in 2025, Optimus robots are working actual shifts in Tesla factories right now. Not demonstrations, real production tasks. They're handling materials, organizing components, performing assembly work that used to require human hands. The current version, Optimus 2.5, has reached a level of sophistication that's genuinely surprising. These robots maintain balance when pushed, manipulate objects with precision, and learn new tasks through AI simulation. They've been documented vacuuming floors, folding laundry, stirring pots, and handling delicate items without breaking them. Tesla had them serving popcorn at company events, tasks requiring navigation in unpredictable human environments. What changed between the laughable 2021 announcement and today? Tesla rebuilt the entire platform. The movement systems are now smooth and deliberate. The AI processes real-time sensory data and adjusts actions accordingly. Most importantly, the robots operate in unstructured environments, not just controlled factory floors, but actual homes and public spaces where conditions constantly change. Optimus Gen 3 launches in the first quarter of 2026, and Musk's description is striking. It will look like a person in a robot outfit. The engineering is refined enough that you won't see exposed wiring or obviously robotic features. The hands are designed to be human-like in appearance and dexterity. These robots can work 24/7 tethered to power, eliminating charging downtime. Musk claims each unit could deliver 5 times the productivity of a human worker annually simply because it never needs sleep. The Gen 4 version coming in 2027 pushes further. Operating time doubles from 7 to 12 hours untethered. Movement speed increases significantly. Hand dexterity improves to the point where the robot can open bottles and pour liquids, not just fetch them. Musk has even suggested Gen 4 could perform surgical procedures with precision beyond human capability. The price target sits at under $20,000 once Tesla reaches production of 1 million units per year. Musk's stated goal is 1 million robots annually from the Fremont factory, scaling eventually to 10 million, then 100 million globally. But this is where things get uncomfortable. Musk has publicly stated that AI and robots will replace all jobs, making work optional for humans. He frames this as eliminating poverty. Robots provide cheap labor and incredible medical care. Whether that's visionary or dystopian depends entirely on your perspective. What's undeniable is that a $20,000 robot working continuously without wages would fundamentally alter labor economics. The competition is taking this seriously. Boston Dynamics has Atlas, which is superior in athletic capability but has no clear path to consumer affordability. XPeng announced their iron humanoid robot, claiming they'll sell more robots than cars within a decade. China is pushing aggressively into this space because they understand the strategic implications. Tesla's edge is optimization for mass production and practical affordability. Optimus is designed for real-world tasks at a price point accessible to average consumers. Whether they can actually deliver that at scale is the defining question of the next 3 years, which brings us to the most controversial announcement. A working flying car prototype exists in Texas right now. That's confirmed. Top speed of 155 miles per hour in flight mode, vertical takeoff and landing capability, price tag of $6,789 with pre-orders supposedly opening by year-end. The vehicle uses a foldable wing system that retracts for road driving and extends to 12 feet for flight in about 60 seconds. The propulsion system uses ducted electric fans, not exposed propellers, powered by a central motor, inspired by SpaceX's Falcon landing technology. Carbon fiber and titanium composite construction keeps weight manageable while handling aerodynamic stress. 3 electric motors, 2 for road driving, 1 for vertical thrust. The 4,680 battery cells provide 350 miles of road range, or roughly 310 miles of flight time. Charging takes 30 minutes from 10% to 80%. The noise level sits at 65 decibels, equivalent to normal conversation. Safety systems include backup batteries, automatic emergency landing protocols, a full-body parachute, and 360-degree radar and LiDAR for obstacle detection. So how does Tesla justify a $6,789 price when current eVTOL prototypes cost hundreds of thousands? Same strategy as the tiny house. Single-piece casting using GigaPress, automated factory production, leveraging platforms from existing models, mass production scale. But here's where reality intrudes. Flying vehicles must meet aviation standards exponentially stricter than automotive regulations. Every component requires hundreds of tests, simulations, crash scenarios, extreme weather conditions. A software error in the air is catastrophic. The regulatory challenge is even more severe. The world doesn't have clear laws for personal flying vehicles. Tesla needs to work with aviation authorities globally to create new standards. Air traffic management systems, pilot licensing requirements, urban infrastructure. That process typically takes years. Right now, production is limited to approved customers in regions with experimental flight infrastructure. Musk envisions mass adoption before 2030, people flying to work instead of sitting in traffic. The technology exists. electric propulsion works, autonomous navigation is proven. But combining all of this into a consumer product that's safe, affordable, and legal? No company has solved that equation yet. What's at stake if even one of these products succeeds? The tiny house addresses a global housing affordability crisis. Optimus targets labor markets worth tens of trillions. The flying car could create an entirely new transportation industry. If Tesla delivers on any single front, the company's valuation could exceed its automotive business entirely. But if all three projects drain resources without scaling, it becomes the most expensive strategic miscalculation in tech history. Musk is betting Tesla's future on simultaneously revolutionizing housing, labor, and transportation. The next 24 months will answer whether he's an engineering genius or an overextended entrepreneur, spreading resources too thin. The tiny houses are shipping now. Optimus Gen 3 launches Q1 2026. Flying car pre-orders supposedly open late 2025. Those three timelines will tell us everything we need to know. So here's the bottom line. Tesla just announced three products that sound impossible. A $7,999 house already shipping in California, a $20,000 robot launching Q1 2026, and a $6,789 flying car with working prototypes in Texas. The real question from the beginning was whether Musk is overextended or ahead of the curve. And here's what the evidence shows. Tesla doesn't need all three to succeed. If just one scales to mass production, it justifies everything. The tiny house is already proving the factory model works. Optimus has gone from joke to functional worker in 4 years. The flying car faces the toughest regulatory battle, but the technology exists. 2026 is the deciding year. Optimus Gen 3 launches in Q1. Flying car pre-orders open by year-end. Tiny house production either scales or stalls. We're not talking about distant futures. These timelines are months away. So which product do you think breaks through first? The house solving affordability, the robot replacing labor, or the flying car eliminating traffic? Drop your answer in the comments below. If you want to stay ahead of every development as these timelines hit that subscribe button and turn on notifications for Tesla Zone. We're tracking every move Musk makes, the wins, the delays, and the surprises nobody sees coming. And if this breakdown gave you a clearer picture of what's actually happening versus the hype, leave a like so more people can cut through the noise. This is Tesla Zone. The future isn't waiting. It's unfolding right now, and we're here to break it down. See you in the next one.